We are studying that the center of mass of a body is a point where a force produces acceleration but no rotation due to the force. What is center of gravity? Center of gravity is also a point lies on the body or where total weight W equals to mg. So center of mass may lie or may not lie, and center of gravity also may lie or may not lie on the body. Okay, so suppose this is a hollow sphere, so its center lies over here by symmetry. Okay, but it is hollow from inside, so it is not lying anywhere on the body. So center of gravity and center of mass may lie on the body, may not lie on the body. Okay, what is center of gravity? Center of gravity is a point where total weight of the body appears to act. So if you hold this body, if you want to hold this body, if you want to balance this body, you need to apply the equal and opposite force to its weight, so then it will be balanced at this point. We want to balance it, this rod, so it will be balanced if you give a support over here at this point at the center of gravity. Okay, and applying the same force upward as its weight. Now when g is same, when acceleration due to gravity is same, or you can say it's uniform throughout the body, then the center of mass and center of gravity, they lie on the same point. Now we have this rod over here in this question. So where is its where will be its center of mass or center of gravity? So its center of gravity will lie at this point G. Okay, so center of gravity lies here. So what does this mean? It means that we will take this is the point where total weight appears to act. Total weight of the rod appears to act. That is equals to mg. Okay, so that is the advantage of center of gravity. Now we have in this question metal bar 70 cm is given to us. Metal bar is AB, so AB is equals to 70 cm. Now 4 kg means its mass is 4 kg, the mass of the rod. So what will be the weight of the rod? That is equals to 4 into 9.8. Okay, this much newtons. So how will you calculate 4 into 9.8? 4 into 10 is 40 and 4 into 0.2 is 0.8. So 40 minus 0.8, 39.2 newtons. Okay, so this is about rod. Now 40 kg in mass, supported on two knife edges placed 10 centimeter from each end. So these are the knives which are placed at 10 centimeter and 10 centimeter. So students, you need to take SI units. So all these units which are in centimeters, you need to change them into meters. So 70 centimeter means 0.7 meter, 10 centimeter means 0.1 meter. So these units are in centimeters. Okay, now next point, 6 kg load is suspended at 30 centimeter from one end. So here this is the load suspended over here, and it is this load is 6 kg. So load its weight is W1, that is equals to its mass will be m1 into g. What is its mass? Its mass is 6 kg. So 6 kg into acceleration due to gravity 9.8. So 6 times the 60 minus 6 into 0.2, 1.2. So 60 minus 0.2 is 58.9 Newton. So that is the weight of the load. So that's W1. So we have this force pulling the rod downward, this force pulling the load downward, and it is at a distance, this load is at a distance 30 centimeter, means 0.3 meters. Now we have to find the reactions at the knife edges. So this rod is supported by the knife edges. So rod is applying the force on the knife and the knives are applying the force. So that is according to Newton's third law, equal and opposite forces are applied at the knife edges. So we have reactions R1 and R2. So these are the forces R1 and R2, and we have to calculate these forces. So our target is to find R1, what is R1 and what is R2. Okay. Now this rod, you can see that it is in equilibrium. So the rod is in equilibrium. So rod in equilibrium. So it is in mechanical equilibrium. So there is rotational equilibrium as well as there is a mechanical equilibrium. Okay. So rod in let us write first mechanical equilibrium. So the state of the rod is not changed, it is at rest and remaining at rest. So it means the net force acting on it is 0, it is in mechanical equilibrium. So mechanical equilibrium means the net forces applied on it is 0. Is it okay, students? Yes? Say yes or no.
Yes, sir.
So rod in mechanical equilibrium means the rod is in translational equilibrium. So for translational equilibrium, we have the net forces. So this is in these forces are in all these forces are along the see, let us take this very important sign convention that I am going to take here. This is what you need to draw with all the figures. Okay, this is your x-axis, this is your y-axis. So of course this will be minus y and this will be minus x. Okay, so this is what we are going to take. So tell me where how many forces do we have here? First, weight of the rod downward. Second, load means weight of the load, that is downward. So two forces downwards and reaction. So this is the third force, R1 upward. This is the fourth force, R2 upward. Okay, so we have only 4 forces and they all are along so 2 of them are along R1 and R2 are along the positive, along the towards the means along positive y-axis, and W and W1 are minus y, along minus y direction. Okay, so it means they are in translation equilibrium. It means the net forces along the y-axis is 0. Okay, so simple thing, force positive and negative, So take the positive force first. You can take along positive y. What are the upward forces? So upward forces we are taking as positive. So plus r1 plus r2. And downward direction we are taking as negative. So minus w and minus w1. So the net will be 0. Okay. Now for rotational equilibrium, so you have got this equation. You put the value of W1 and W2 here. Okay. So after putting the value of W1 and W2, this equation you will get R1. So let us simplify it further, and you will get R1 plus R2 equals to 98 newtons. Okay, simply add them, that is 98. Okay, and this side it will be negative, this side it will become positive. So this is your equation number 1. Now for rotational equilibrium, because mechanical means translation as well as there is no rotation. For rotational equilibrium, so first translational and then rotational. So for rotational equilibrium, we'll have sum of all the moments of forces, means all the torque will be 0. So torque, what is the direction you are going to take? Like here you were taking the direction means along the like x-axis and y-axis, means so upward direction positive, downward negative. But here, what direction you are going to take? So we have to draw that direction over here also, students. So the direction that I am going to take is like, if there is a rotation, if I am taking the moment in the anti-clockwise direction, so this is anti-clockwise direction. So anti-clockwise direction, so this direction I will be taking the tau as positive. So student, this is what you need to draw, okay, in all the figures, so there will be no problem. Now this tau, you know, tau is equals to R cross F. So you have to take R and F. So put your fingers on R and move them towards F. So here, how many forces do we have? We have 4 forces. It is written over here: R1, R2, W and W1. So what is the torque produced by each force? What is the resultant torque due to each force? So the torque due to each force you can write it as in magnitude we can write it as tau is equals to R F sine theta, and you know that this is F into R sine theta, and this tau is equals to F into R perpendicular distance, right? So this is R perpendicular. We also call it lever arm. This R perpendicular is lever arm. So we need F and we need to multiply it with the lever arm R perpendicular. Okay. So we need what do we need? We need force and we need lever arm. That is R perpendicular, that you can say R sine theta. Okay. And then this is your F, force F, and then multiplying these two, you will get torque. So tau is equals to F into R perpendicular. Okay, so we can make a table. Is it okay? Let us make a table. Okay, one by one. So what is our first force? First force was our weight of the rod, that is W, downwards. What is the lever arm over here? See, next thing is that students, we have to take the we have to choose a convenient point. We are going to take the moments about. See, you have a choice. You can take the moments about any point, about A, about G, about B. You will get the same answer where the rod is rotating. Okay, so let us take G here. So moments about so you are taking the moments about G. Okay, so moments about G. So this is what you need to write. Moments about G. So you have to measure, so you can consider G as origin. You have to measure your distance R from G. Okay. Now, what is this for W? This is your G, and what is the distance? This R perpendicular is the distance. So this R perpendicular is the distance between. What is this distance between? Yes, tell me. What is this distance between V now? This R perpendicular? Yes. What's this distance between?
भूल गई सर.
Huh?
भूल गई.
Forgotten? This R
Yes.
See, we have this force over here, and suppose this is the point where I am applying the force. Always, whenever you forget, take the example of the door. This is your door. Okay, this is the top view of the door, and this is your hinge. Okay, and this is your door, and here you are applying the force. You want to open this door, so you are applying the force. There is a handle over here, and you are applying the force over here. So there will be rotation motion. So you are applying the force F over here. Okay, so this we call line of action. This force extend this line. Okay, what do we call it? Line of action. This, and this is your axis of rotation. This point, at this point you will have axis of rotation. Yes. So the distance between the line of action and the axis of rotation, that perpendicular distance is your R perpendicular. Okay. So what
Okay,
is this
sir.
distance between? This distance is between line of action and axis of rotation. Okay. So the shortest distance between them. So now what is the distance between this where you are applying the force and from where you are taking the moments? So you are taking the moments at G. Okay, you are taking the moments at point G, and the force is also at G. So in this case, what is R?
Zero.
R is 0. Okay, because you can see that the distance between, because here the force is also at the same point and axis of rotation is also we are taking as g, passing through g. So W into 0 is 0. Now next force we have is W1. Okay. Now tell me, what is the lever arm for W1? This is your G here. Okay. And that's your distance. That is because this is the force here, that is W. So what is the distance here? This distance,
5 centimeter.
yes, this distance PG. This is your point P. So what is the distance between PG? So here your lever arm is PG. So what is this lever? How much is the PG? See, this is 30 and this is 35. AG is 35. So AG minus AP, right? And that comes out to be 35 minus 30, that is 5 centimeter. Okay, and you can write the 5 centimeter as 0.05 meters. Okay, so what is your torque here? This 0.05 into W1. W1 you have already calculated. Okay, so this multiplying these two, or here you can write 0.05 into W1. Okay, now what is the next force? That is R1, right? So R1, same thing. This is your G. Where is your R1? R1 is over here. Okay, so this is your G and R1. Which point is this? This is this point you are taking as K1. Okay, now where is the force we have? The force is in upward action. So one more thing, students, we have not taken this sign. Is it positive or is it negative over here? Yes. See, you have to rotate your fingers from direction of R to direction of F. So where is your direction of R and where is the direction of F? See here, like here, this R is over here and you are applying the force in this direction, downward direction. Okay, so that was the means your direction from R to F. So R, they are supposed to be joined by the tails. So this is the direction of F, this is the direction of R. So that was the direction of R, that's the direction of F. So from R to F, so this direction was negative. Okay, so let us see here, what direction is it? This is your R. So this R is actually this R is from axis of rotation to the point where force is applied. So from R, this distance G to P, that is your R. So G to P, this direction. Okay, so G to P. So this R, so this direction of R, this is the direction of F. So R to F. So this, which direction is it? Yes, which direction is it? This,
Outside the paper.
okay. It is coming out of the plane of the paper, the direction. Okay, direction of tau. But here are we going to take it positive or are we going to take the tau negative? It's
Positive.
positive. It's anti-clockwise, so we'll take the direction positive here. Okay, so this is the third thing that we need to third thing means force and lever arm and then the direction. Okay, now R1 is upward now. Sorry, the force is upward now, that is R1. And what is the direction of this R? Means the position vector. So from G to K. So this time the direction is this and force is this. So what's the direction here? So R
Positive.
to F. So it's this time it is clockwise, right? See, this is your G, this is your point K1. So G to K1, that's your the position of K1 from G to K1. Now where the force is applied? Force is applied here upward. So that's where force is applied. That is your reaction R1. Now tell me this R cross F. So this is this direction is R to F. So you can even write here R. You can write here even F. So from R to F. So where is your R? This is your R. Where is your F? This is the direction of F. Okay. Sorry. This is the direction of R. And this is your direction of F. So this is the force here, this R1. So R to F. So R to F. Okay. So this direction is clockwise, that we take as negative. So here this direction if you are taking as positive, so opposite to this direction, that is clockwise, we take as a negative. So here it is a negative. Got it?
Yes, sir.
And we also draw these directions over here. So this direction you can see that see this you were taking this R over here, and so from G to K1 this was your R, and this is your force. So R to F. So R to F. Okay, and this is clockwise direction, that is negative. Now look here, next for R2. So for R2, so let us calculate R1 first. Means this lever arm. What is lever arm here for R1? This is GR1. So we can write it as R1G or K1, sorry, not R1, K1G. So K1G is equals to how much? So this AG minus AR1, and that comes out to be 25 centimeter, that is 0.25 meters. So this comes out to be minus 0.25 R1. Okay, now R2, this is your R2. So what is the direction of means position vector of this point? So starting from G, yes, from G to this point, that is the direction of position vector R. So that's the position of R, and this is the position R2. This is your force here. So R to F. So R to F. So that's the direction. So that direction is, we are taking it as positive. Okay. So here the direction we have taken is positive. Now what is the lever arm distance here? This is the lever arm distance, the distance between G and point of application of force, that is K2G. So K2G is also same as K1G, so that's also 0.25 meters. So that we can write as plus 0.25 R2. Okay, so here you have G over here and K2 over here. So G2 K2 where the force is applied, so that is your R. This distance is your R, and that's the direction of R, and the force was applied R2, that is upward. So that's your R2. So from this position vector direction to the force direction, that is this direction. So that direction is positive. So direction of tau is positive here. So now we have to simply add these three. So we will get delta tau, means summation tau is equals to and that is equals to 0. So we'll get one more equation here. 0.5 W1, 0.25. So put the value of W1, you know the value of W1 here, that is 58.9. So put the value 58.9 here and multiply them, you will get a constant, okay? And then plus minus 0.25 R1 plus 0.25 R2. So here you will get an equation after solving this, that will be R1 minus R2 is equals to 11.6. So you will get the equation from here. From here you will get the equation R1 minus R2 is equals to 11.76 Newton. So you have two equations. So always you will get two equations, one from translational equilibrium and one from rotational equilibrium. And then solving these two equations, you will get the value of R1 and R2. So this is what we need to do. Okay. So I hope that you have understood this question. So students, keep on writing simultaneously, then only you will be able to understand it in a better way.
सर आपने लास्ट में क्या किया है?
This equation, this is summation tau equals to 0. So what is summation tau? Adding all the taus. So I have 4 taus. 0 plus 0.5 into 58.9. This is your W1. So 0 plus this plus this plus this. So adding these 4 values equals to 0. Adding all the forces equals to 0. That is your translation equilibrium. What is rotational equilibrium? Adding all the torque equals to 0. So adding all these 4 torques, okay, and equating them to 0, and I will get this equation R1 minus R2 is equals to 11.6. So how do I get this? This is simply, I have added them, means 0 plus 0.05 into 58.9, that is a W1, minus 0.25 R1 plus 0.25 R2, that is equals to 0. Okay, this is what?
पर सर ये तो 0 आया ही नहीं.
What is not equals to 0?
जैसे W1 पे जो फोर्स लग रहा है वो.
W1 पे फोर्स लग रहा है,
हाँ टॉर्क मतलब.
हाँ, तो W1 पे जो टॉर्क लग रहा है, that is equals to 0 plus 0 की तो it is not required. तो what, multiply these two, what do you get? 9 5 the 45, 5 8 the 40 and 4 44. So 5 5 the 25 29. So that's and 2.945. And taking these two on that side, so you will get 0.25 common, and this R1, the negative will become positive and positive will become negative. And now you will get, further you solve it, so this will come this side, so 2.945 divided by 0.25, that is equals to R1 minus R2. And simply dividing them, you will get R1 minus R2, that is equals to 11.76 Newton. This is your equation number 2. So this is what I have written over here. R2 minus R1 is equals to 11.76 Newton. So now you can equate these two equations. This is equation number 1, this is equation number 2. Add both the equations. So you will get 2R1, R2 will cancel out, and that is equals to 98 plus 11.76. So you will get, after solving this, you will get R1 is equals to 54.88 Newton. And now from, so here you are adding first and second equation. You'll get this. Now put the value of R1 in equation number 1. So from first, R2 is equals to 98 minus 54.88, and you will get R2 as 43.12 newtons. So that's your final answers. Value of R1 and value of R2. Is it okay? Yes, students, is it okay now?
Yes, sir.
So note it down. If you have still not noted it down, note it down. So after this we have the next question, example 7.9. From the this is the third day that I am teaching the same concept. So students, unless and until you will do it all by yourself, just by looking at the video, you will not be able to understand physics. You have to write it with your own hand, you have to solve it with your own hand, doing it with completely understanding, step by step. Then only it is going to help you out. Okay. So next question. हाँ हाँ, कोई फ़र्क नहीं पड़ता. अभी दरवाज़ा बंद करो, उस दरवाजे को बंद करो, दोनों दरवाजे बंद है, पानी भरो, क्या दिक्कत है? ये भी बंद कर लो और बाथरूम का भी बंद कर लो. ओके, इज इट ओके स्टूडेंट्स?
Yes, sir.
Yes.
Shall we move forward?
Yes, sir.
Okay, next example is, so you have to do this question now in the similar manner. Okay, so you have a 3 meter long ladder. So this ladder is, you have a ladder which is 3 meters long, and you have a frictionless wall over here. So this is the frictionless wall. This is wall. Important point is that it is frictionless. So what is the, and then you have this is floor. And this is rough floor. This is rough floor. So we have frictionless surface and we have rough surface. So what is the meaning of these two? That is very important for us to understand. See, whenever there is a frictionless surface, we will have only one force over here, that is perpendicular to this surface. The surface which is frictionless will have only one force which is perpendicular to it. Okay, but when we have the rough surface, then what will the reaction force here? So here the reaction force was, so this ladder was applying the force on the wall, and wall was also applying the force on the ladder. So here the resultant force was only perpendicular to this, the reaction force. Now we call it, let us call this force F1. Now when the surface is rough, so then the force applied means the reaction force. This will be your reaction force. So this will be your reaction force. So here they have shown it separately, this F2, not along the ladder, but it is supposed to be means along the ladder. So that's your F2. So these F1 and F2 are the reaction forces. These are the reactions, F1 and F2, due to the surface. Like earlier on, there were reactions due to the knife support, right? R1 and R2. So here also these are. But here you can see that as the surface is rough, so it is this force along the ladder and this force is perpendicular to the wall. That is the meaning of frictionless, and that's the meaning of rough. So as a result, we will have two forces here. So if we resolve this F2, we'll get two forces. One is the perpendicular component and one is horizontal component. So these are the two forces. Of course, this ladder, this is a ladder, and this ladder is at rest, it is not moving. So who is which force is not allowing it to move? This force is your frictional force. This is the frictional force that is in this direction. Okay, so the force is your frictional force. So this is your frictional force. The component of this reaction force F2 is frictional force. This is the frictional force, and it is not allowing this ladder to slide down. And what is this force? This force is perpendicular to the surface, so this is the reaction force. Okay, so this is the reaction force, that is normal force, we can call it N. So this F2 is resolved in two components, frictional force and the normal force. And here we have only normal force because the wall is frictionless. Is this clear?
Yes, sir.
सर जो रिएक्शन फोर्स है वो हमेशा परपेंडिकुलर नहीं होती, जैसे यहाँ पे F2 स्लांटिंग बना दिया आपने.
हाँ, अच्छा क्वेश्चन है. मीन्स see this force, we call it the normal force. See, this is the normal force is your actual reaction force that is perpendicular. So F2 is resultant of frictional force and normal force, that is your reaction force. So the reaction force is N. So N is your reaction force. Okay, and F is your frictional force. This frictional force, this F, and F2 is resultant of this reaction force and friction force. So F2 has part of reaction force also. So this F2 is equals to N plus F.
और सर जो फिगर में F2 बना रखा है वो गलत कैसे है?
आप उसको ले लो F2. You can take that F2 also. उससे कोई फर्क नहीं पड़ेगा. Main thing is that we have this normal force perpendicular to the surface and we have this frictional force, and the resultant of these two forces is F2. That is by parallelogram.
Okay, sir.
You can take it otherwise also. You start from F2 and resolve it into two components, N and F. That's your choice. So this F2, if you particularly want to write about F2, so F2 is the force. Who is applying these forces, this F and N? Who is applying these forces?
Floor.
These forces. Huh?
Yes. Who is applying these forces?
Floor.
Huh? Floor, yes. So F2 is the force, is the net force applied by floor on ladder. So that is what F2 is. F2 is the net force exerted, applied by the floor on the bottom of the ladder, on this bottom of the ladder. Okay, is this clear now?
Yes, sir.
Or you can further say that N and F are forces applied by the floor on the bottom of the ladder. So this is what you can say. So how many? So again, now this ladder will also have a center of gravity. So at center of gravity, it is being pulled by the earth. So that's the weight. So we have center of gravity here is written with point D. That's your point D. So that's, so now how many forces do we have here in this question? So we started with F1, so force number 1. Where is force number 2? That is your so this F2 is resolved in two components. So you can take this frictional force as force number 2, this normal force as force number 3, and this weight as force number 4. So here also you have 4 forces. Okay. So here again, this is in equilibrium. So we will have the translational equilibrium as well as rotational equilibrium. So this ladder is at rest. It is given its feet at rest on the floor 1 meter from the wall. So this distance is 1 meter from here to here. That's given to us 1 meter distance AC. So AC is equals to 1 meter. Now we have to find the reaction forces on the wall of the wall and the floor. So reaction forces, so means you have to find F1 and F2. This is what you need to find in this question. Okay, so a simple thing.
Excuse me, sir.
Yes.
Sir, how you get to know that this is in equilibrium?
It is given here. Its feet, ladder, its word is used for ladder. Ladder's feet at rest. Word rest is over here on the floor. So this ladder is at rest on the floor. So when there is something at rest, state is not changing. So if the state is not changing, it means it is equilibrium. And when there is equilibrium, here it is mechanical equilibrium. So if it is mechanical equilibrium, then means there is translational as well as rotational equilibrium. So we have, so translational equilibrium means sum of all the forces is 0. So one equation you will get from here. Rotational equilibrium means sum of tau equals to 0. One equation you will get from here. So we have to take the sign conventions, that this is plus x-axis this direction and upward is plus y, so of course opposite to them is minus x and minus y, and then we have to take the direction of the torque. So if it is the direction of torque is in this direction, means anti-clockwise, we'll be taking it as positive tau. So that's what we need to draw with all the questions. This is the first thing that you need to draw, the sign conventions. So these are the sign conventions that we are taking. So for translational force, we are taking this sign convention, this x. So if the force is in along the means horizontally, so if it is in towards the right hand side, we'll taking positive, towards left hand side we'll taking negative. Upward force positive, downward force negative. Tau, so there can only be two directions, clockwise or anti-clockwise. If it is if the movement is anti-clockwise, we'll taking it as positive. If the direction is clockwise, we'll taking it as negative. So then we need to take the sign conventions. Okay, so now there is no problem. You have two equations and you know the sign conventions, so simply you can now it's very simple to solve. And next thing you need to take is where you are going to take the moments about. Okay, where is this axis of rotation? So at which point you are, so tell me, here you have the choice B, D and A. Where you are going to take the moments? Tell me. If you are taking if you are taking the moments about B, then you have to calculate the distance of the forces from B, like distance of F W from B, this F from B and N from B. So variable will there will be larger variable, means you need to write three equations. One will be 0. So if you are taking a D, then again distance from B to D, and then N and F from B. So again three variables you will have. But if you take the moments at about A, so the advantage is that from here the distance of N, R for N is 0, for F also is 0, because the axis of rotation and the forces are acting at the same point. So here the tau is 0 due to N and due to F, because R is 0 at A. So that is why it is advantageous. You are cancelling two variables here. So that is why it is advantage. So this is what you need to decide. To taking moments about A. Okay. So this is what you need to decide. So A, this is your, now this A is your means here you have axis of rotation passing through it perpendicular to the plane. Okay, so what are the things that you are going to take in all the questions? First thing is what you are going to take. You have to write all the forces. Okay, so what are the things that you are going to do? First thing is, in all these questions you have to select the object to which the equations of equilibrium are going to be applied. So where is your object which is in equilibrium? And second, you have to draw a free body diagram, like I have made here this free body diagram showing all the external forces. So showing all external forces. Okay, so then what will the third thing you are going to do? You need to you need to choose a convenient set of x-axis and y-axis and resolve the forces into that component. So even if there is certain force which is like here I had F2, so I have resolved it into components N and F. So means take all the forces along x-axis and y-axis. So resolving all components, resolving all forces along x-axis and y-axis. So taking the conventions, which direction you are taking as positive and which direction you are taking as a negative. So this is what you need to take. So along with the x of rotation. So this is your x and this y. You need to draw it, okay? This positive, this positive. And now fourth thing you need to do is you need to apply the equations now. Force along x-axis will be 0 and force along y-axis will be 0. So these are the two steps, third and fourth, which are related with the translational equilibrium. Okay, so translational equilibrium. So you will get these two equations. Now what about rotational equilibrium? So fifth step you will be taking convenient axis of rotation. First of all, you need to take this x, this y. Okay, so this direction you are going to take is positive tau. So this, like here you have taken the directions of the forces, here I have taken this direction, and in this direction will of course be negative tau. This is the same direction, sorry. This is the same direction, this direction, clockwise, minus tau. Okay. Now you have to, next thing is that you need to identify the point where the external forces act on the object. Okay, and then we have to calculate the forces produced about the chosen axis. So you have to choose the axis of rotation. So you have to, like here we have chosen here moments about g. Moments about what we have to, moments about a we are taking in this question. Okay. And what is the next thing that you need to do? Next thing you need to do is taking tau equals to 0. So that is your rotational equilibrium equation. So students, these are very simple thing that you need to do in all the questions. Object where the force applied, which is stationary object, means object at rest, and then you have to draw the free body diagram showing all the forces, and if they are not along x-axis and y-axis, then resolve all the forces along x-axis and y-axis, and then you will get summation x and summation y as 0 because there is translation equilibrium. Now choose the axis of rotation and the sign conventions for the torque. So anti-clockwise positive and clockwise negative, and then rotational equilibrium tau equals to 0. Okay, so this is how you need to solve these questions. So stepwise, so very simple. Any questions?
No, sir.
Okay, so solution. Now translational equilibrium, that is your step number 3. We have already taken these sign conventions, plus x and plus y. So obviously this is minus x and this downward will be minus y. So now step number, so this was step number 3. Step number 4, resolving all the forces along means translation equilibrium. So sigma fx will be 0 and sigma fy. So all the forces along x-axis 0, all the forces along y-axis 0. So now let us write the forces along x-axis. So which force is along x-axis? So you have four forces, 1, 2, 3 and 4. So this force is along F1, this force is your N, this force is your F, and this force is your W. So these are the 4 forces that you have. Okay, so you can make a free body diagram showing only these 4 forces. Okay, so this was your step number 2, free body diagram showing all these forces. So now tell me which force is along x-axis. So F1 and F. So this is along negative x direction. So that is minus F1. and this along positive x, so plus f. So minus f 1 plus f, and that's equals to 0. Now what about force in vertical direction? So these are the force in vertical direction, that is W and N. So N is vertically upward, so we'll take N as positive, and W is downward, so we'll taking W as a negative. So we get two equations from here. So F minus F1 is equals to 0. This is equation number 1. Okay, this is equation number 1, and this N minus W, that is your equation number 2. Okay, now we have the means same way we will draw a means this step number 5. We have chosen this axis, and now rotational equilibrium. So rotational equilibrium, tau is equals to 0. So tau, you know, that is equals to r perpendicular into f. So we are going to take that. So let us make a table for that, for all the forces, like we have made the table earlier. So what do we have here? So we need to find this tau. Okay, so first thing you can do is you can make a diagram also of this particular case. Now you have to write the force, and then you have to write the perpendicular distance, that is your lever arm, or you can say that is your r sine theta, and then you will be multiplying. Tau you will be finding for particular case, that is, this is the force F, suppose this is r perpendicular, so F into r perpendicular, that is your tau. Okay, so diagram will tell you whether the tau is positive or negative. So for all the forces you can draw this. So let us start with what's the first force that we have here, that is F1. So let us write it for F1. So what is the diagram for F1? So this is your, the axis of rotation is at A, right, and this is the point where your force applied, that point is B. So this is A, this is B. Okay, and this is your ladder. So this distance is, where is your R? Starting from A to where the force applied. So from axis to point where force is applied. So where the force applied? So force is applied at point B in this direction. So your R is from axis of rotation to the position vector of the where the force applied. So here to here, this is your position vector, that's the direction of your R. So what will the direction of the torque? So that is, this is your R, this is your F. So R cross F. So which direction is it? Is it clockwise or anti-clockwise? Anti-clockwise. So anti-clockwise, the torque will be positive, right? So right here positive. So this diagram will tell you whether the tau is positive or negative. So here the tau is positive. Okay. Now the force which is applied over here is F1. So this is what we need to find. We don't have, and what is this perpendicular distance between the line of action? See, this is your line of action. This is your line of action, and this is your axis. So what is the distance between line of this perpendicular? This is the perpendicular distance. Okay, so always extend the, so in this figure, this is your point A, this is your direction R, so this was your direction tau, negative tau. Now what is perpendicular R? R perpendicular means this is your line of action, this force, this is your line of action. Okay, so the distance between axis of rotation and line of action, this perpendicular distance you are going to take, this one, and this is 3 and this is 1, so this will comes out to be, this height is 2 root 2. Okay, so that's this lever arm is 2 root 2. So this is so the torque is equals to 2 root 2 into F1. Similarly, you can find for the next force that you have. Next force you can take as F. So this friction force, and so for friction force, this R perpendicular is 0. So for F, R perpendicular is 0. So that is the advantage of taking the axis of rotation at A, right? So for N and for F, for N also, R perpendicular is equals to 0. So tau is equals to 0 for case number 2 and case number 3. So for both the cases, tau equals to 0. So now we are left with only one case, that is the force, that is W. Okay? So now let us take this W. W is at point D, that's your W, and this is point A. So that's your axis of rotation, and what's the direction of force? So that's the direction of force. So what is the direction of R? This is the direction of R, from axis of rotation to the point where force is applied. So this is your R. Okay, this is your R, and this is the direction of R. So from R to F. So from R to F. So which direction is it? Clockwise or anti-clockwise? So anti-clockwise, right? So negative tau.
Clockwise.
Sorry. Yes, sorry. Thank you. This clockwise direction. So this negative. Now this the force is W here, and what is the perpendicular distance? Now this is your line of action. Yes, this is your line of action, and this is your axis of rotation. So line of action and axis of rotation, draw a perpendicular over here. So that is your R perpendicular. So that distance is what is the distance here? See this distance, this FE. This is your F. A. This is point A and this point E. So this is your point A and this is your point E. So the distance AE. So half of FC, that is equals to, so A is 0.5 meter. So 0.5 meters. This is your perpendicular distance, and this comes out to be this tau is 0.5 F W. Okay, and you know the value of W. W is equals to m into g. So what is the mass of the ladder which is given to you? That is 20 kg. So 20 into 9.8. Okay, so that comes out to be 196. So, and half of 196 is so that is 0.5 into 196. So half of 196 is 98. So that's 98 Newton. And so you have the equations. Now 3 equations you have. One equation here you will get from here, summation tau is equals to 0. So that is 2 root 2 F1 plus, so this is your minus, sorry, this is your minus, yes, this tau is minus over here, so that's minus, so that's negative 0.5. We have calculated it 98, and that's equals to 0. So we have these equations. This is equation number 3. So students, put the value here also, that the equation we have written over here, that what was it? Summation y. So here this force N minus W is equals to 0. So put the value of W over here also. And what is the value of N? N is also the same as W. Okay. So N, how the N is same as W? Put the value of W here. We have calculated 9.8. So N minus 98 is equals to 0. So what you will get? So you will get N is equals to 98. Okay, from this equation. So put this value N is and 98 over here in this equation, equation number 2, and you get N. So you know W, you know N. So out of the 4 forces, you know two of the forces. So now you are left with only 2 forces, that is F1 and F. And you have the 2 equations So from here you can calculate F1 also. Okay, so F1 will be equals to 98 upon 2 root 2. Yes, so F1 is equals to 98 upon 2 root 2. So you can calculate F1, and this comes out to be 34.6 Newton. Now you have calculated F1. So now you put this value of F1 in first. F1 is equal to F2. You see this negative will become positive going this side. So F is also, so from first F is also, so from first F is also 34.6 Newton. So what was your target? To find the reaction forces. So first reaction force is which was perpendicular to the wall, that is clear, that is your, so you have to find F2 and F1. So F1 is you have got F1, that is, and now F2. So F1 is your 34.6 Newton you have calculated. And now what is F2? So F2 is, this is your, these are their forces, this is frictional force and this is the normal force, and the resultant of this was your F2. So this is your F2. Okay, so F2 is this length is N, this length is F, right? So F2, magnitude of F2 is equals to under the root N square plus F square. You know the value of N, that is under the root 98 square. You know the value of F, that is 34.6 square, and solving this you will get 199 Newton. That is your F2. Okay, so, and what about the direction of F1? Because this is a force, so you need to tell the direction also. The direction was this was the direction, so means perpendicular to the wall, away from the wall and perpendicular from the wall. What is the direction of this F2? Suppose this is making an angle alpha here. So what is tan alpha? Tan alpha is equals to perpendicular upon base, so perpendicular is N upon F. So that comes out to be, so what is N? N is your we have calculated the N over here, that is 98, and we have calculated the F over here, that is 34.6. so that comes out to be we can take it in root also, students, keeping it 2 root 2 like 98. We can write it as 98 upon 98 upon N. The value of N is 98 and the value of F is 34.6, so that is 98 upon 2 root 2. So 98 will cancel out, and this is N by F. So see W, where are we wrong? See, what is W equals to? 196. Nobody is telling me. W is equals to 196. So here W is equals to not 98. W is equals to, we are putting the value of W there, right? Not the value of torque. Not, so we have put the value of torque over here, 98. This is not 98. W is W. This is the value of torque. We have substituted wrongly. Okay. So this so again N over here we have, students, N minus W, this value is equals to 0. W is 196 we have calculated, and N is equals to W. So N is equals to W is equals to 196. So here also instead of 98 there will be 196 square. Okay, and here also this N is 196, not 98. 196 upon 98 into 2 root 2, and this will comes out to be 98 to the this 2 times, so this is 4 root 2. and we get the value of so tan alpha is equals to 4 root 2, so alpha is equals to tan inverse 4 root 2. So tan inverse 4 root 2, that's the value of alpha, and that's means you can leave it over here. So I hope that you have understood this question.
Yes, sir.
Okay students, that's all for today. Thank you so much.